from many different parts, it helps probe different parts of the atmosphere, which is very useful. Let's go to the next one. Oh, okay. This is just a close-up of what I said. This is where I'm going on May 30th to make the observations there. And they have a 50-centimeter telescope. Yes, this is the Bosca telescope. And let's go to the next. Okay. Anyway, that gets the idea. So now we go to the documents that I wanted to step through, the step-by-step how we make the observations. So where's that camera? Oh yeah. So let me show you. Let me show you. Very simple. It's very simple. But there are a couple things. So GPS for the time. This can measure the time, make a timestamp to as good as 1 microsecond. Very important for occultations. So this gets put here. And yeah, so that's all for that. Then this one is, this has a thermoelectric cooler. So the chip, it doesn't work at room temperature. It needs to be about 0 degrees Celsius. So yeah. And then right now it's 12 volts to cool the detector. So we have some adapters, but this is for a car cigarette lighter, but we have adapters. So, and then finally, yes, exactly. In fact, Australia, they will be using this. Yeah, and all the telescopes in Australia we all use exactly the same camera, which is handy. And then we plug the camera into the laptop, and we use software, which I will describe. So, and this goes on the telescope. Oops. Oh, yeah. This goes on the telescope, either a 2-inch or 1 1/4 inch adapter right on the eyepiece. We have to get the focus right, so I have some extenders also, if necessary. I understand the one telescope here is 2,800 millimeter focal length, and another one is 1,000 millimeter. And so both those will work well with the camera. You can see the chip, it's in there. So since we all use the same equipment in Indonesia and in Australia, we expect to have consistent results between Australia and Indonesia. Okay. So, yes. Let me, yeah, thank you. Let me go through this document because I sent them out, but I think it helps to talk about it and to use the software. Maybe tomorrow we can practice with the software tomorrow morning. So because this is only words, and if you see the software, it's quite easy to use, but we have to practice, I think. So, you know, this is very simple. Turn on the computer. The screen will show a picture, how to log in. All the laptops are the same. It's not this laptop, but some laptops that I brought with me. You have to plug in the camera power to a 12-volt supply, as I showed you. And you turn the power supply on. And you will hear a fan when this turns on. So you have to listen to it, hear the fan. Yes, yes. And then you plug in the camera to the laptop. It has to be USB 3. So the laptops I bring have USB 3. Now there's a system where we can automatically find the star field. However, we decided that for Indonesia, we will not use that system. We need to manually find the star field because I thought that you in Indonesia, you would be good at finding the star field. The automatic thing is very tricky, and I didn't want to mess with it. In 2011 at Bosca, we found the star field manually with no problem. But that was a 60 centimeter, right? 60, yeah. So
that is because of the expertise of Irfan.
Yes, Irfan did that. Right?
Irfan is a very excellent pointer.
Yes.
Better than a machine.
Yes, right, exactly. So, and of course, we have to be guiding at sidereal rate when we set it up. But we have several days to find the star field. So I think we can practice. Once we've found the star field, then everything becomes easier. So I'm not going to use this ASCOM system for automatically finding, but it's interesting because the way it works is you take a picture of the star field and it goes to a online system called astrometry.net, and it calculates where you are. So it automatically will tell you how to get there just from a picture that you take, which is quite amazing. So the software we will use is called SharpCap. It's and I'll go through that tomorrow. So this is all simple. Nothing wrong here. Yeah. So on SharpCap, you have to connect the camera, and you drop down menu says QHY174 GPS, and you click on that. Usually that works. If the camera does not show up in the drop-down menu, we have to restart SharpCap, but that's okay. That's also easy to do. Now, the SharpCap software requires many different settings: the exposure rate, the gain, and I'll talk about those. Those we all set in a profile that we have to load the profile, which is already on the computers, to set the gain and the rate. But as I mentioned, the rate will depend on the telescope, the aperture of the telescope. So we want to do some experiments before the occultation, where we take the observations just like we will during the occultation, just to get data on the occulting star, the occulted star. In order to optimize the signal to noise ratio, and that will depend on mostly the aperture of the telescope. Okay, so we will not be driving the telescope with our software. We're going to do that manually with the hand paddle and instead of using the software, because I think that will be easier for us to do in Indonesia. But, okay, let's go to the second document. Okay. Yeah, so there are many options on SharpCap. And so I will talk about the options that we will set for this observing. The default says mono 8. We want a 16-bit because we need a lot of high quality data. The image size is 1920 by 1200 pixels. We will do no binning because we want the sharpest images. And the output file, default output is like a PNG file, but that's no good for us because we want the FITS files that includes the header information. So we have to make sure that we're outputting FITS files from these observations. So the exposure, in this case, it's 500 milliseconds, which means 2 images per second. We don't know yet what the way I've set it up now, we have it for 1 second exposure. We may be able to make that faster. Gain of 300. these are all in the drop-down menus. Let's see, frame rate limit maximum, amplifier noise reduction auto, offset 100. I don't know what all these are. USB traffic 40, no live broadcast, and we want force still mode off. The GPS, which is very important because the timing of the event is critical. So we want the GPS on, we want the GPS calibration LED off, and the calibration is handled automatically. Let's go to the thermal controls. We go up. Yeah, so we set the cooler power to auto and the target temperature to 0 Celsius. So that's important to cool the detector down to get low noise. And we can use a histogram to look at the quality of the image. And we will not use the scope controls because, as I said, we will manually be finding the star field and tracking using the telescope sidereal rate and not the software.
Mark,
Yes.
what is the stability of temperature that you need?
Stability.
Yeah.
It probably isn't very critical.
It's not.
And I've heard that the temperature, it cools down very rapidly because it's only cooling the chip. So it takes about a minute to cool down. But it would even be possible to do these observations without the cooler. They just wouldn't be as good. So I think it keeps it within 1 degree. Yeah. Yeah. Okay. And we can go to
Peak to peak variation
Yes.
is 1 degree.
Right. So, yeah, let's go to the final document. Okay, so here are the steps for the observation. The star, we have to set the telescope to these RA and DEC. This is the decimal, and this is the RA time. These are very close to the same, the different format. And so the first thing, and these are J2000 coordinates. So the first thing we do is we go to this spot and we try to identify the star field. I don't know if we'll be able to see Pluto, but we'll be able to see the star, and that's the important thing. Okay. As I mentioned, the following is not necessary if we find the Pluto star field manually. So we don't need to use ASCOM, which is the system that connects to the telescope and orders the telescope to move. We're not going to do that. We're just going to use hand paddles. And let's go up. Okay, these are practice stars, but we don't need these. Let's go up some more. Okay. And there's the star field, which I showed before, I think. Let's go up a little bit more. I think now I don't know. This is the star field if you're looking without any changes. So depending on the telescope, some telescopes flip east-west, some flip north-south. This is unflipped. And I think the things that we'll see is this triangle, that should be easy, and also these 3 stars. Hopefully we'll be able to do this before the actual night so that we're confident that we have the right spot in the sky. Now, as I mentioned, as Pluto goes over the star, so if we take images once every second, we're getting data, 4 kilometers every 4 kilometers in the atmosphere, which is very, very useful. The scale height of the atmosphere is about 16 kilometers. So we're getting 4 measurements per scale height, extremely sensitive. I should mention this field is 17.7 arc minutes by 11.1 arc minutes. So it's a pretty small field. Probably we will see a larger area than this. And this would just be in the central part, depending on the magnification of the eyepiece and the focal length. I think that's it. Let's see if there's more. Oh yes, so these are instructions for the practice night. which was 2 nights before, and then the dress rehearsal night, which is the day before, or the night before, and then the event night. Now, the idea is we only need to take data for 10 minutes, 600 seconds. And what we're going to do is, to practice, is from 1615 UTC to 1625 UTC. So that captures the star before it goes behind Pluto, and then all the way out. So it's a lot of work for only 10 minutes of data, but it's very, very precious data because to me, scientifically, it means that we can understand if the atmosphere of Pluto is freezing out under the surface or not, because there are theories both ways. There's one theory that says the atmosphere will never change or won't change much. And there's another theory that says that the atmosphere could be rapidly freezing out, the nitrogen freezing out onto the surface. And so we just don't know enough about Pluto right now to know if that's happening. If it does freeze out, that means that most of the time Pluto has no atmosphere, and it only has an atmosphere when it's closer to the sun. So like in 1988, and so it's an important question for understanding the climate of Pluto. There's more scientific issues also. If you're near the center line of the shadow, like in Australia, there's if you look at the light curve, it goes down and under. But if you're near the center, you can get what's called a central flash right at the bottom of the light curve, and that's a result of the light leaking around the atmosphere and showing whether the atmosphere is spherical or not. So we can't do that from here because we're too far off the center. That's a very interesting part of our campaign. Australia may see that, but they may not. We don't know. Oh, and also, let's see. These are some details. We have a log sheet that we want to fill out properly for each image sequence. We put the time, start and end of the capture. Anyway, these are detailed instructions on how to fill out the log sheet. We want to put the latitude, longitude, and altitude of the observatory. We write down the number of the camera. This camera is 007, or no, just 07. It says NSF because these cameras were purchased by the United States National Science Foundation. So we're grateful for their support because they really helped help us make these observations. So the observations in this whole campaign is funded by NASA, but the instruments were bought by the National Science Foundation. That's a typical arrangement for supporting astronomy in the United States. And let's see, use a new log sheet for each night, practice nights, the event night, and then some other suggestions. Make sure there are no flashlights and that the laptop screen is not too bright so that it doesn't interfere with the observations. It's important to keep the target star near the center. It doesn't have to be that close to the center, but we need to keep the target star fixed, and that will depend on the telescope. Some telescopes are good at tracking. Some telescopes may need a manual adjustment, and it's okay to make a manual adjustment even in the middle of watching the occultation. But you have to use a lowest rate possible for guiding, so there's no smearing of the image. And that's, yeah. So, and also do not walk around. Apparently, I don't think this is a problem in Indonesia because it's very humid. In a very dry climate, when you rub the floor, You can create static, and that makes the data incorrect. You don't want to rock around with flashlights. And also over-guiding is sometimes a problem. You don't want to change the position very rapidly. Yeah. Well, I'm sorry? Yes. Okay, yes, that's right. That's right. Yeah. So I did test the cameras when I was in Jakarta to make sure that they run on the electricity, no problem. Yeah. Everything these days now can run on, most things can run on 120 and 220. Yeah. Let's go up a little bit more. Yeah. Okay. Oh, and then this is, Leslie wrote this. She wants us to turn in the log sheet each night because she will be checking everyone's log sheets and data every night from many different places, from Indonesia and from Australia. So we will probably be in touch with the teams in Australia also. So I think tomorrow I can show you the SharpCap software and go through these steps one by one, and we can, show you exactly what the practice night will look like. Also tomorrow, I'd like to talk more about the science and show some more images from New Horizons, because the Pluto is a really interesting place. Yeah, I'll talk about that tomorrow. It's so much more complicated than we expected. It's not just a ball of rock. It's got lots of ice that's moving in and out of the atmosphere. It has 3 different kinds of gases that can condense: nitrogen, methane, carbon monoxide. And the mountains are made of water ice that is very hard at 40 Kelvin surface temperature. So it turns out to be a very, very interesting place. And I think it's wonderful that we can add to the body of science to understand the atmosphere. So I think that's all I have for today. Terima kasih.
Okay, terima kasih, back, Mark. So we have 2 sessions previously from Dr. Hakim, also from Dr. Mark Pulo. So for anyone who wants to ask, actually for setup and for observations, can also ask both in Indonesian and in English, as well as in chat room as offline. Anyone want to ask? We still have 30 minutes. So yeah, plenty. Do you want to? So we have Mr. Adit here. Okay. So he will be the.
Sure. Yes, please.
Oh yeah, or maybe later after the session. So anyone offline can do it. Okay, please. We have one question from Mr. Adit, who is the POC for ITERA.
Yeah.
Observation side.
I want to ask about the filter we will use in the night.
Good question. Okay, so in order to maximize the signals and noise, we will use no filter, open filter. In Australia, on some big telescopes, they will be making observations with a blue filter and a red filter, and that helps because that will tell you the color difference will tell you whether you're looking through a haze. The atmosphere is neutral color, so but the haze will scatter light, more blue light than red light. So if you use a filter, you can determine whether there's a haze, and we're not going to be doing that. It's not necessary.
Yeah. About that, if we use the color camera, is it possible or not?
Yes.
Oh.
Yes, it's possible. Although this camera is not color, so
yeah. We have one color camera. Maybe we can install it in the second telescope.
That's a very good idea. Yes, that could be very useful.
All right. I think that should answer the question. The other wants to ask some question. Is another Mr. Adit want to ask?
Okay.
No. Okay. Anyone from chat True. Oh yeah. Okay. We have another question
Yes, sir.
from Dr. Muchira Harto.
I would like to know whether if you pull down the camera to 0 degree,
Yes.
it is not I mean, there's some water tube.
Water condensation.
Yeah.
Yeah, that's a good question. I don't know. I think it's sealed. I think
Oh,
it's sealed, but I hadn't thought about that. I think I'll test it out tonight to see whether that happens. It's a good
because
question.
It's
Yeah.
very humid in this
Yes.
country.
Yes.
Sometimes some water and, and telescope.
Yes, on the telescope too. Yeah.
Optical telescope.
Yes.
If we use for a long time.
Yes.
Growing.
Yeah.
But I don't know.
No, that's a good question. I see that there's a glass over the chip, and I think it's sealed. So I think it's not going to get water inside,
Yeah.
but
Outside.
outside, yeah.
Yeah, outside. Yeah.
Dude, right, right. Good point.
And then some light from the Pluto,
Yeah,
not 100%.
right. Yes. Sure, sure. Yeah, yeah. 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 When I make observations of Venus in Hawaii, it's up high, 3,400 meters. Sometimes it's so humid that we have to use hair dryers. Yes, yes.
So yeah, basically maybe humidity is the problem. So yeah, need to prepare
Yeah.
before the event. So
Yeah.
we have another question for Mr. Mr.
Sure.
Adit again.
Yeah, about the humidity, yesterday and 2 days ago, we try the use this camera.
Uh-huh.
So now, I think if the humidity is above 97%, it's starting to
Yeah,
very condensed on the telescope, but not in the camera.
I see. Yeah. In Hawaii, they close the observatory when the humidity is above 90%, above 90, because of that problem. But here it's often above 90. So yeah. Yeah.
But we, as talked by Mr. Hakim, we use the hair dryer or just blow. It's at W. The
Yeah.
W533 MC
Nice.
color camera.
Yeah. Thank you.
In discussion about humidity, yeah, because we are living in a
Another
humid
question?
country. Another
Good.
one, okay. Yeah, it's good so that anyone in chat room
So
think about question.
about the guide, guiding the guide star.
Yes.
Will we use the manual guiding or just use the software?
I think manual guiding is
Manual
best.
guiding,
Yeah. It's only 10 minutes, so I think we can keep the star, and it doesn't have to be perfect. So as long as the star is, is near the center, it's fine.
Once again,
Yeah.
about the focus, it's be perfectly focused or just smart.
Yeah.
Okay.
The focus is important, so we have to practice getting the star focused. Yeah. That's why I have some extenders if we need to move the camera to the focal plane. No eyepiece. Yeah.
I like to invite people from Bosca because I think several people from Bosca are online here. So what is the current status of Bosca preparation? Because Bosca changed actually the telescope from 51 centimeter to another telescope. So maybe Agus or Danang, who are in the Zoom, could you say something about this, please?
Okay, please, if there is a representation from Bosca Observatory to tell us about preparation there.
I'm sorry, what was the question? Oh,
Oh, report from another
Ah.
side.
Actually, I should mention, Hakeem is taking I have 3 cameras. He's taking one to Bosca, right? With the laptop. Yeah. Yeah. Right. Yeah.
I think Bosca people is here, but the situation of Bosca is like this. At first, we plan to use the 51 centimeter telescope, but that is a Schmidt telescope.
Okay.
It is short, a fast telescope.
Yes.
But we are worrying about the critical sample
Yes.
because it might create a very big field.
Yes.
And we fear that Pluto only occupy 1 pixel or something like that. So you have any?
I have a adapter to change the focal length, like a yeah. So you can take one of those, so that will change the focal length, and you can see if that helps. Yeah. So we have that option to put the adapter in to change the focal length.
Maybe Agus, could you respond on this, please?
Yeah, Mr. Agustriano from Pusat Observatory, if you can give us some notes on preparation on Pusat. I don't seem that there is any response from Pusat. Yeah. All right, maybe when we wait, we will continue with another question if there is any. Any more question? Anything simple is okay, and anything in Indonesian also fine. Yeah,
Yes.
yeah.
Yes.
Or yeah. Okay, yeah. If not, yeah, I will be the one who asks. So basically, after the event, we will submit all the logs, right? So do we have data from other sites as well, or basically just send everything to Leslie and team?
I'm sorry. Say that again.
Oh yeah, basically how about the data? So everything will be sent to team
yes.
USA, or we can
Yes,
get
good
the
question.
data altogether?
So I have yes, that's a good question. So I have a thumb drive, 256 gigabyte thumb drive. We get a lot of data, and so we'll put it all on that thumb drive, and I'll bring the thumb drive back to me. But of course, we leave a copy here for you to analyze if you want. Yeah, yeah.
Okay,
So
so basically just for that site only, about not from like Australia or something.
Yes, yes.
Australia and as well as Posca and
Yeah.
Itera. Okay, so that maybe answer anyone who curious about what the data will be like.
I should also mention, although Leslie will be processing the data, we can all be involved if we want. So we should, after this event, we can collaborate on analyzing the data to try to derive the pressure and temperature of Pluto. I think that would be very exciting. It's a very interesting data reduction. So we should collaborate on that after the event.
Okay. Any more question? If anyone have some idea, okay. We have another question from Dr. Mut.
Yeah, it's very nice camera. So we can if we use this camera, so we simultaneously we can get 3 color data.
Yes, it's possible. Yes. If you want to use filters, we could do that. Right now, the plan is just to use open to get the best throughput, to get the most light. But especially, yeah. So right now, I think our plan is just to use no filter. But it could be impossible. It could be possible to use different filters. That would be very valuable for possibly detecting the haze. So I can talk to Leslie about that and see if she wants to do that. Yeah.
So no, it's just a white light color.
Yeah. Yes. Yes. Ka-ching.
I just would like to know expected of lifetime of this camera is several years.
That's a good question. Probably, yes. I think many years. Yeah.
and how to check the stability of
Yeah.
the camera? Do you know?
No, I don't know. Yeah. Probably you could make observations of known stars like the star Vega, which we know the brightness very well, and we could measure that over a long period of time. Yeah.
Have to use several times.
Yes. Yes. Yeah. Because it's a CMOS CCD, it probably is very stable. Yeah. Yeah. Although the cooler is probably the most problem. It may break after many years. I don't know. But the output from the sensor does depend on the temperature of the sensor. So there's a question of the temperature stability and how that affects the output. Yeah. But the manual, I think, has some information about that, the SharpCat manual. I mean, the camera manual.
Okay, also we have Vicky from Kala who wants to ask question. I assume you want to ask directly without using the chat room. Okay, thank you for the discussion about the lifetime of the camera and some record. I think we need to look at the data sheet again to see what it will be in a few years. Yeah, Vicky,
Okay, thank you, Miss Kiki.
you
So my
want
name is
to ask directly?
uh,
Vicky
does my
from
sound
the Zoom, from
does my
Kala.
sound audible? Check check. Hello.
Oh, okay. Okay. All right.
Okay, no problem. We can read your question. So what's your question, Vicky? So yeah, he's still typing. So anyone offline who wants to ask as well? From the media, if you want to ask, you curious about anything? Kalau penasaran mau tanya sesuatu, misalnya Pluto itu bagaimana detailnya, coba boleh Pak, Bu. Iya, nggak apa-apa. Boleh, boleh, boleh.
What is your opinion if at Boscia Observatory there is also very long focal length like Zeiss telescope, refractor telescope 60 centimeter, and the focal length is about 11 meters. So if you compare with the Smith telescope, Smith is very short. But spatial resolution for Zeiss telescope may be better, much better.
Yes.
Compared to, and then we can clearly detect the light curve. Maybe,
Right,
maybe,
right.
maybe. But the lens itself is absorb a lot of light. It may be also worse.
Yeah. Yeah.
What is your opinion, or maybe you have some experiences?
Yes. So my only experience is using a Schmidt-Cassegrain, like a Celestron, with a 2,000 millimeter wave focal length, is just perfect. So I have a adapter that can extend the focal length or reduce the focal length. So no matter what the focal length is, we can probably use this camera, for short or long telescopes. Because if we're using a refractor with a very long focal length, we just put the focal length reducer on here and make effectively shorter wavelengths, shorter focal length. Yeah. Yeah. In fact, let me see if I can find it.
Yeah. You didn't have any problem with the custom, Mark?
No.
Oh, so that's good then. Okay, so yeah, it's all good during custom. Okay.
So here's a focal length reducer. So a focal length reducer. So we can put this. Yes, and put this in. Yeah. So put this in, and then oh, okay, yeah. So so this will help if the focal length is too long. I have other adapters too, so yeah. Aha, good. Yes.
Yeah, design wise, I think 1 hour, but printing more than that.
Yeah. So
Yeah. But our telescope here is not as large as Bosca, for example. So we don't need a CNC machine, but instead a 3D printer can. We have already make some various adapters, right?
okay, good.
Yeah.
And I brought many adapters too, so I think we can make it work. The one thing that I'm concerned about is the 12 volts for the cooler power. I have one adapter that can go to a lab power supply, 12 volts, but only one, and we have 3 sites. So we have to worry about how to get the power to this, because this is for people who are using their car and they drive out to the desert and they make, like in Australia, they will use this. But so that's the one challenge that we have to deal with. Yeah.
So yeah, basically we have 12-volt adapter, but not the car. Yeah, basically not the car function. But the other port is
So
just a normal 12-volt
Yeah.
plug, right?
yes.
So
So we can cut this and then make it go to 12 volts.
Yeah, Mr. Adit who knows everything.
Yeah, good.
Setting that
Yeah.
up here in Itera, but maybe in Posa and also in Kupang can basically organize beforehand. So basically Vicky from Kala, the Lampung
Yes.
astronomical community. Okay, so how far we are going to analyze Pluto's atmosphere? Does it simply to confirm the existence of the haze, or also further to know how far do we know about Pluto from this occultation for the atmosphere?
You mean what altitude or?
Basically, what information
What
we can
information?
obtain from
Yes.
occultation of Pluto for the atmosphere?
Yeah, that's a good question. I think the answer is what we produce, what we be able to determine from these observations is the profile of pressure and temperature. And that alone will tell us about the chemistry, because most of the atmosphere is nitrogen. smaller amounts of methane and carbon monoxide. So I think, I'm not an expert on this, but I think that that will help constrain the mixture of the atmosphere. But that's not my field so much. So, but I think just the pressure and temperature alone, if you use models, you can determine how much methane and carbon monoxide is there.
Okay, so basically the atmospheric compositions can be, basically can
Yes.
be examined or determined during
Yes.
the occultation. But I think for atmospheric dynamic, it needs a longer observation than just
Yeah.
10 minutes maybe. So yeah, maybe that can answer your question, Vicky. Any other question? Okay, we have Mr. Adit. We have microphone. So please.
Just ask about because the camera is using GPS. Maybe is there any specific requirements for GPS placement the antenna for my forest, or it's just placed anywhere? As long you get GPS lock, or there's specific requirements, so you have above ground or like that?
You mean for the GPS?
Yes.
Yes, that's a good question, because in 2011, we had a GPS, but it didn't work inside the dome. We had to take a wire and go all the way outside the dome for the GPS to work. And I think this GPS has a similar problem. It's best that it's outside, but the cable is not that long, so we might have to figure out how to extend it. But we'll just try it and see if we can get the GPS signal. If not, we have to add length to this cable, I think. Yeah, and the GPS is absolutely necessary for these observations.
Yeah, hopefully I think I have like antenna connector extender. So hopefully if not long enough, I will connect to your antennas.
Yes,
It will work.
right. It's a good question. Yeah.
All right, thank you. So discussion about the GPS has to be installed, but maybe cannot be installed inside the dome. So it's a point of interest to make sure that it works. Anything else? Okay, we have another question.
Sure.
For another Mr. Adit, so we have to Mr. Adit here. Hopefully, no one will get confused.
Our telescope is f10.
Good.
Is good, or we use reducer again?
I think F10 is good. Yeah.
It's good.
Yeah.
Is it fast enough, or?
Yes, it's fast enough.
Yeah, thank you.
Yeah, because the telescopes we're sending to Australia, I think, are F8, F10. So yeah.
All right. Do we have any more questions? So it's basically about the speed of the cameras. And if there is no more question, okay. Yeah, nothing else. I have 3 seconds for anyone else in chat who wants to ask. 3, 2, 1. Okay, we have question. So yeah, we have question here from Api Arami, who is a student in our department. Why for this Pluto observation, it's a collaboration between Indonesia and Australia? And what can be obtained during this occultation? Yeah, so basically why it's Indonesia and Australia?
Yeah.
And the second one, so what can be observed or obtained during this whole research about occultation on the 1st of June?
Okay, so the reason it's Australia and Indonesia is that just happens to be where the shadow of Pluto falls on the Earth. And, it's been 11 years since that happened before. But I should mention that this is just Pluto. There are many objects in the solar system that we can measure with occultations, like Titan is very important because we're sending a spacecraft to Titan. NASA is sending a space. So getting the profiles of Titan is very important. So when it comes to Pluto, the shadow isn't very big, and it happens to be in Indonesia and Australia right now. But there are many other objects like, Jupiter or Jupiter's moons or Titan, where occultations could happen here also. But so it's just the geometry of the star and Pluto that allows the occultation to happen here, as it did 11 years ago with a different star. But I just emphasize that there are many, many opportunities with different objects that will go in front of a star where the shadow will appear in Indonesia. So I think it's worthwhile to build up the capability in Indonesia to look at occultations, because there are many places that can, many objects that we can explore using occultations. But yeah, in terms of what we learn, you know, the most important thing I think is the pressure and temperature of the atmosphere from, you know, I don't know how far up, a few hundred kilometers, when we start seeing some dimming of the star down to the surface in that light curve. And of course, there is even some atmosphere above that, but I think this method is not sensitive enough to measure the very highest part of the atmosphere. To me, the most important part is the surface, because that's where the atmosphere is possibly freezing out. And so we really want to know what the surface pressure is. That is how massive the atmosphere is and how it's changing.
Okay, thank you for the answer. I hope that answer the question. Intinya karena geometri, jadi lewat di Indonesia dan Australia untuk tahun ini. Sebelumnya pernah juga lewat di Indonesia tahun 2011. Dan sebenarnya okultasi itu bukan hanya Pluto saja, jadi banyak, termasuk untuk Titan, karena juga menarik juga atmosfer untuk Titan. Jadi intinya ingin belajar tentang apakah profil dari atmosfer Pluto, terutama yang lebih dekat permukaan, karena yang lebih dekat permukaan, jadi kita ya karena atmosfernya kan makin lama makin tipis, dan metode ini juga lebih bisa dipakai untuk atmosfer yang lebih dekat permukaan. Semoga menjawab juga ya dalam bahasa Indonesia. Okay, any more questions? Okay, we have another question for Mr. Alka.
The question from Apri Arabi is inspire me for something about occultation method for studying atmosphere of other planets or other objects. Can it be the occultation method can be study such kind of ocean or some kind of liquid in the planet?
Oceans on other planets?
Yes, liquid. No. This method is try to understand how the atmosphere on the planet or on the planet. But can it be to understand the ocean or the ocean?
Yes, that's a good question. Well, certainly if there are geysers, if there are, geysers pushing up from the surface, like on Enceladus, and the geyser is happening where the star is going behind, you could probably see indirectly the ocean underneath the surface. So I don't know if that's ever been done, but that's a good idea. We could, so I think in theory, it would be possible to search for an ocean on Enceladus or Europa by looking at occultations. Yes, that's a good question. You have to be lucky, but if you did it, it would be very, very, very good research, very interesting research.
Okay, thank you. Yeah, there's a possibility, but it depends on the.
I'll talk to Leslie about that.
Okay.
That's a good idea.
So interesting discussion about whether we can see ocean from occultation, not just atmosphere. So we have questions for Mr. Danang from Observatory. He wants to ask about the CMOS temperature. Will it affect the SNR for the observation? So is there any difference between no temperature regulation regulated CMOS or the temperature regulated one?
I'm sorry.
Temperature from CMOS, is that important for the SNR?
Yes.
Signal to noise ratio?
Yes.
And is there any difference between the CMOS that is basically temperature regulated or no temperature regulated?
I don't think there's any temperature related. Yeah. I mean, as I said, it can work without the cooler, but it's a little noisy, and then the signal to noise ratio will be bad. But so to get uniform results, we want it at about the same temperature each camera, and the 3 observatories be around 0 Celsius.
Okay, so basically it will affect the SNR.
Yes,
Yeah.
yes, yes.
So yeah, that will answer your question, Mr. Dana.
Just to
Okay,
well,
to add from-
yeah, reiterate this,
Dr. Hakim.
Mark. Because not only 3 cameras that you bring will be used for occultation observation. So
Right,
this question come from those who might not use the camera.
sure.
So
Yes.
the question is, should this be temperature regulated CMOS camera, or
Oh.
we can have a
No, I think
Hmm.
you can make useful observations without the lower temperature. Yeah, so an uncooled camera can also be very useful.
so that would be advisable to use
Yes.
cool camera.
Yes,
So I hope that answer your
that's
question.
good. That's a good question. Yeah. I mean,
Okay.
many astronomers in Australia are using cameras without coolers for, to help with this program. So yes, that's good.
So yeah, basically it will affect the SNR, but yeah, you can still have good data with even without the temperature regulation. But
It is
yeah,
advisable to
visible to use, but yeah, still better if you can get the one with the
Yes.
temperature regulation. Okay, is there any more questions? So we
Maybe,
have another
maybe the
question.
student will want to ask.
Oh
but,
yeah,
need
from
to
student,
tran-
yeah, it's fine.
but need to translate a bit.
Yeah, no worries.
Selamat pagi semuanya.
Oke, selamat
Izin
pagi.
perkenalkan diri Bu Bapak, nama saya Deborah dari program studi sains data.
Oke.
Jadi kan tadi saya melihat ada visualisasi yang di PowerPoint, ada beberapa visualisasi. Kemudian saya tertarik bagaimana cara pengolahan data ataupun tadi pasti ada data yang diambil ketika udah di kamera gitu. Itu untuk mengolah datanya bagaimana gitu sehingga diperoleh banyak grafik-grafik okultasi tadi. Terima kasih.
Okay, so yeah, masuk prodi SAP. Enggak. Oh no, basically she's from the data science department. So basically she wants to ask from the data that has been observed, so how to process that so that we can get the curve
Yes.
occultation and to get the atmospheric profile from that. So basically how.
Yes, good question. So I've been reading some papers on how to do that. It's a very detailed mathematical inversion, but I can send some papers on how to do that. Yeah. Yeah. Okay. So I will send some papers on what the procedure is to turn the data into useful information about the pressure and temperature of the atmosphere of Pluto. Okay.
Okay, thank you. Ya, basically intinya cahayanya nanti dibentuk kurva lalu dibuat transformasi inverse untuk mendapatkan bagaimana profil atmosfernya yang didefinisikan dalam publikasi yang nanti akan dikirimkan atau bisa dikirimkan dari tapi bisa ikut kegiatan OIL juga untuk yang bukan astronomi atau punya basis SAP, sering-sering ikut kegiatan OIL agar tahu bagaimana cara-cara untuk mengolah seperti ini. Okay, any more question from the audience offline and online like? We still have 10 more minutes. Or if anyone or everyone's already satisfied, so hopefully, another one.
Okay. Thank you. I drink some water.
Okay, we have another question.
Yeah, Mark, here in Indonesia, Milky Way is a very, very,
Up high.
yeah, very high. So, why is it not so many occultation I heard? Because central of Milky Way and ecliptic.
Yeah.
will
Yes. So from what I understand, 10 years ago, Pluto was in the galactic plane, and there were many occultations. But nowadays, it's moving away from the Milky Way, so not so many stars for occultation. It's because Pluto is not in the ecliptic; it's tilted
But it's not, I mean, it is not necessarily only Pluto, but maybe other
Oh, absolutely. Yes.
solar system
Objects. Yes.
object,
Yes.
maybe across the Milky Way.
Yes.
Central,
Yes. I
and
think
a
it
lot
would.
of stars.
Right. A lot of stars in the Milky Way, so that helps. And I think right now the most important object is Titan, the moon of Saturn. And I don't know the schedule, but I'm sure there are occultations visible from Indonesia in the next few years. So, in fact, I think what I'll do is I'll talk to Leslie about that, and I can send you a list of possible occultations that will be happening in Indonesia.
Oh yeah, basically, if anyone from data science wants to make a database, basically there are a few basically applications and software that has calculated those. But if you are interested, or anyone who are interested in big data can also do that to knows about schedule. But basically, yeah, maybe Titan will be a point of interest for occultation. So yeah, we'll get the schedule, or there is possibility to observe from Indonesia. So another question from Mr. Danang from Bosca Observatory. Is it feasible to observe it with the CCD camera, because we use CMOS, right? Even with enough short exposure time.
Yes, yes, that will work fine. Yeah.
Okay. So how to compare with CMOS then in this observation?
I'm sorry, say again?
No, basically he will use CCD, and
Yes.
then what's the difference with observation with CMOS for this case?
Well, I think the main factor is how quickly you can make images. We need, as I mentioned, we need to make one image per second. So some CCD cameras can do that and some can't. So it depends on how fast the frame rate you can get. Yeah.
Okay, so the frame rate will be more important than the time
Yes.
of the camera.
Yes.
So I hope that answered your question.
Yes, I have.
Okay, another
Just I have a comment on
another
this
note,
one, Mark, because
from
we usually use a CCD, but
Yes.
in time delay integration mode,
Okay.
which means that actually we deployed CCD as a video.
Yes.
Yes, inline transfer. But it, of course, the challenge is in the past we used for example, the Santa Barbara instrument group CCD OOPS, which is equipped with this. But at the moment that controls, that acquisition system is now become obsolete. And the new feature does not so much include the time delay integration feature.
I see.
So that means that we have to search for this appropriate acquisition system that facilitate common CCD to be used in time delay integration.
I see.
So that's maybe the challenge of an astronomer who like to make a high time resolution using a conventional CCD camera.
I see. I see.
And the noise is also still high for CCD camera, unless
yes.
we cool down to minus 10 or 15 centigrade, something like
Yes.
that.
Yes.
Okay, thank you for the comment on CCD observation. So yeah, basically those are the things to note if you want to observe with a CCD camera. Any other questions? Or yeah, I think we only have 5 minutes. So short notes from each of the speakers.
Don't be so tight with time.
Okay.
Because it gives an impression that we are in rush. Don't worry, be relaxed, please.
No. It's a relax. Just it's quite long discussion session, which is good. So hopefully everyone learned about Pluto and its occultation, and basically short notes for today's lecture, from each speaker.
Yes, I'm not supposed to close actually, but we are still in the middle. Yes, I think to all colleagues and participants in the Zoom and as well as in person here, thank you very much for all the attention for this half session actually from the whole things. Tomorrow our session will be from me. I will talk about the general science with occultation, because at Bosca Observatory we made lunar occultation collaborating with NARIT, for example, and we also like to, of course, promote this in ITERA as well. And yes, occultation by a solar system object is something that really interested. So equipped with the standard CCD camera or CMOS camera, you don't need a filter, for example, but then you can still do significant science with even small telescope, as small as 20-centimeter telescope. So I hope you have a good impression on and motivation from all the presentation that has been delivered today by Mark and myself, and looking forward for having a practical session in the afternoon, Mark. So after having lunch, we have to unfortunately break this session first because you're going to have a press discussion, people from the press, for about maybe one hour. So please drink first. And then after having a Friday prayer break and lunch, okay, then in the afternoon we start at 1 o'clock. In the meantime, I'm not suggesting you to go back to the hotel because the hotel is far away from here. Yeah. So, but here I hope Emersia is about 30 minutes by car. So, yeah, Mark will be with us here. So that's all for closing this before we go to the next session. Thank you very much. Give a big hand to Mark and myself. Thank you very much.
Thank you.
Thanks to all in the Zoom as well.
Okay, do you have any conclusion or short notes for today?
Just to reiterate what Hakeem says, it's the opportunities with occultation are very great because we only have limited knowledge of the atmospheres of the objects in the solar system. So there is much to be gained by doing research in occultations, and I think it's a promising field.
Yeah, thank you for both of the speakers. Don't forget that we still have sessions tomorrow, and yeah, basically everyone can come early, and we also basically getting better from today's session and learn so that tomorrow we can see everyone again, hopefully in the Zoom session and offline, bright and early. Thank you. See you tomorrow.